this is Andrew Smith, rolling mill metallurgist and AS&T Level 3 with SSAB. I'm here today, Monday, June 28th, 2021, in Nashville, Tennessee, and we're here to conduct an AIME oral history capture of Richard Rick L. Bodnar, retired director and co-founder of SSAB America's Research and Development Facility. So Rick, tell me about where you grew up.
I grew up in New Jersey, Brook, a small town in a very densely populated county of Bergen County. I was born July 1st. I have a birthday coming up. I'll be 68 years old. And from what I hear, it was a very hot day, somewhat like it is here in Nashville. Brook is 10 miles from the George Washington Bridge, so I spent a lot of time as a kid in New York City. And it's where the Garden State Parkway actually intersects with I-80. So very, very popular. A lot of famous people would stay actually in Brook in the hotels for going into New York. As a kid, I played a lot of baseball. I played Little League and then Babe Ruth League, that was 13 to 15, and Connie Mack ball, 16 to 18. And I played in high school as well. I also played some basketball in high school, JV team. Believe it or not, as a freshman, I was 5'3", and by the time I was a senior, I was 6'2". So I was really small, and so I only played a couple of years of basketball. I played varsity soccer in high school and then on in college. When I was 9 years old, I had nephritis, a kidney disease. I almost died. I was in the hospital for 17 days and I missed school, so that was kind of a tough time. And I was a good student through high school. I made National Honor Society and graduated 13th in a class of 232.
You had mentioned you'd played varsity soccer and baseball in high school and college. Tell me about some of your other athletic achievements.
Okay. I guess first thing was I made All-Stars in Connie Mack all 3 years when I played. In high school, I was all area as a senior, as an outfielder, and also in our league, which was the Bergen County Scholastic League. I was all first team as an outfielder, but I also pitched. I played first base. And at the end of high school, when I graduated, I got an invitation from the New York Yankees to come to Yankee Stadium and try out, which was kind of a big thing. They had taken the 40 best players, I guess, in North New Jersey to go in, and nobody made the team. Pretty much they sat down all 40 players in the visitor dugout. And they said, well, thanks for coming out. Don't call us, we'll call you. And they sent us. So that was something, and I could tell you in detail all about that. In college, I guess I have the second highest strikeout average per 9-inning game, which still holds 11.4 strikeouts. This was at Muhlenberg College. And then in 1972, the varsity soccer team, which I was part of, was ranked 3rd in the country for small schools, and that team was inducted into the Muhlenberg College Hall of Fame. So I'm kind of proud of that.
That was absolutely extraordinary. Did your parents go to college, and what did they do for a living?
Yeah, both parents went to college. They have non-STEM degrees, and they both have master's degrees from Montclair State University. My father was a high school English teacher, and then for the last 21 years before he retired, he was the department head in Passaic High School, New Jersey, and that's a huge, huge high school. He was responsible for 35 teachers reported to him. So English teachers, reading teachers, special ed, all reporting to my father. Father was a World War II vet, and he passed away in 2008. During the summers, he founded and directed a day camp, Camp Iroquois. And I was lucky as a kid to go to camp as a camper, and also later as a counselor and then assistant director when I was older. And I found that was probably my first management experience. So I learned a lot, that you need to have an agenda, you need to have a plan. So what are you going to do with these kids every day, every minute, every week? So that was a very good experience. My father was also heavily involved with the Boy Scouts. As a kid, he was a scout. He was a scout leader, later as a scout leader. And then my brother is an Eagle Scout. My father was Scoutmaster. I never got involved with scouting because I was always playing baseball. There were always baseball games. But my brother would go away to a Floodwood camp for 3 weeks at a time and come back with 10 merit badges. I mean, it just pretty phenomenal. My mother was a home economist, and she was involved with 4-H in the extension services in Bergen County and Oswego County, New York. So the fairs, she'd be judging, the best pies and all that kind of stuff, organizing all that. And she also was the president of the Women's Club, which is a big deal in Saddle Brook. So she did very well.
Tell me a bit about your family right now.
Well, my wife, Carolyn, she's been my wife for 43 years. She's trained as a counselor and a social worker. We met at Muhlenberg College, and Muhlenberg College being a liberal arts school, we had to take certain classes, like 2 art classes, and I took the art history class. I also took a drawing class, and that's where we met. And my drawing is terrible. I was good at mechanical drawing. I took 4 years of mechanical drawing in high school. But freehand drawing, I was pretty terrible. In fact, my roommates in college, they would often get my sketchbooks out and just be rolling on the floor looking at how terrible I was. And the class, there were nude models, and so one of the most difficult things to draw is the human body and all the shadows and everything. And that's where I met my wife. She was in the class. She was very good. And at the end of class, I guess for the final, we had to do an inking of a hawk. And we both did these hawks and probably put like 20 hours into it. Of course, Carolyn's was excellent, and mine was probably the best artwork I ever did. And for a long time, we had both of the hawks up on the wall in our house. It's kind of a conversation piece. And of course, Carolyn's been very supportive during my career, preparing for papers, and I'm pretty much a workaholic, or have been a workaholic. She supported that, so that's been very good. We have 2 kids. Michael's 39 now, and Meredith is 36. Meredith actually works at SSAB as a truck dispatcher, doing very well with computer systems and making sure deliveries are on time. And our son works for Hologic. He's a lead software engineer. This company makes mammography machines, and so he's writing software, state-of-the-art, probably the best in the world company, and so he's doing very well. We have 3 grandchildren at present, 1 on the way, due in October. Jack, our grandson, is 6. Sienna is my daughter's only child. She's 4, and we spent a lot of time with her, so in retirement, They live in Davenport. We live in Bettendorf. We spent a lot of time there. In fact, my daughter, Carolyn, and I coach 4-year-old soccer, which is kind of back to the future for me because I coached my kids, I think, 13 years straight: baseball, basketball, girls softball, soccer. So that was a lot of fun. And then we have Lucy, who's 2 years old. I have a brother, I told you, is an Eagle Scout. He also works for a Swedish company like I do. They make crystal, and he's the chief financial officer there. And my mother is still living, so we moved my mother to Iowa. She only lives about a quarter of a mile away in assisted living. She's 93. And so we're spending time taking her to doctor's appointments and that kind of thing. So I kind of had to retire. I could not be working full time and helping take care of grandchildren and my mother. And plus, we want to do other things, travel and the like. So.
You had mentioned meeting your wife there at Muhlenberg College, but your degree is actually a Bachelor of Science in Physics. How did that come about?
Well, in high school I was very good in math and science. I got some guidance that you should, be major in chemistry or physics, or perhaps engineering. And I ended up applying to 5 different engineering schools in Muhlenberg. A liberal arts school, and I got accepted. Fortunately, I got accepted to all 6 schools. And a kind of a funny story that we went and visited Lafayette College. So driving from New Jersey into Pennsylvania, and one of the first cities in Pennsylvania is Easton, and that's where Lafayette was. And we visited the school on a kind of a rainy day, fall day. And Lafayette was a lot of hills. And then about midday, we went over to Lehigh. So Lehigh is in Bethlehem, Pennsylvania, where Bethlehem Steel is. I spent a lot of my career there. And again, a lot of hills there. And I love the baseball coach. The baseball coach used to pitch for the New York Mets. And so he wanted me to pitch there. And then we went to Muhlenberg. The sun came out. It was kind of flat. People were friendly. And there were a lot more co-eds. At that time, engineering schools like Lafayette and Lehigh, maybe only 10% of the school were female. And it was, at Muhlenberg, was fairly easy to make the sports team. So I played varsity sports there, but and had a good experience. So Muhlenberg won out in the end. And I got a pretty good education there and was able to make the National Honor Society in Physics, Sigma Phi Sigma. So I was happy with the choice in the end.
I see you didn't stop there in terms of your education. You eventually went on to get an MSc in Metallurgy and Materials Science from the University of Pennsylvania. What and or who were most influential in pursuing an engineering degree?
Well, I as a senior at Muhlenberg, I started to interview, and there's not a whole lot you can do with a BS in physics. So you could maybe run an electron microscope and be a technician somewhere. And I decided that no, I definitely want to do something more. I want to go to graduate school. But I didn't see myself, getting a PhD, maybe teaching, being a professor, teaching physics. Fortunately, I had a very good advisor, very good physics professors at Muhlenberg. Dr. Boyer alerted me to the fact that there was a program between Muhlenberg and the University of Pennsylvania and Columbia University in Metallurgy and Materials Science. And I applied to both, and I got into both schools, and didn't really know what I was getting into, other than you need to know math and science, have a good background, which I did. And growing up close to New York City, I really didn't want to go into New York City, so I selected Penn, and that turned out to be a really good choice. There was a lot of ferrous metallurgy activity at Penn that I really didn't know about ahead of time until I got there. I had summer jobs that dealt with the metals industry, interestingly enough. One was in fine container, where they made these 5-gallon drums, for like driveway blacktop type of thing. And they made paint cans. And I learned about forming and stamping and cutting and actually welding and some heat treatment. Where they would take the lids and put foam on the inside, then that would have to be baked, so kind of a baking heat treatment. I also worked at Thermoelectric, which was interesting. They extruded plastic coating on top of wires. So, for example, the wires have this plastic coating, so I did that. For a while. Of course, you have to splice wires together or weld them together, so I learned some resistance welding. And then the other thing is, I spent a lot of time, they had a machine where you had to load in spools of wire, and the machine turned around and round, and they pulled a cable. So you see these big wooden spools, where they're putting cable down. Yeah, I helped make cable. So that was kind of interesting. So I liked both of those jobs. So I knew a little bit about metals, I guess. And my grandfather was a self-made engineer. He worked for Wright-Patterson and the aircraft business, and he made a lot of the prototype equipment. So he could make tools, he could make parts, prototype parts. And he knew about heat treatment. He actually had books on heat treatment, believe it or not. So I had somewhat of a background. It kind of came together, but I didn't know that it was coming together. I really didn't know what I was getting into until I got to Penn. And it turned out to be a great place to be at school.
Did you happen to take any other additional significant coursework?
Took a lot of courses over the years, seminars, webinars. In fact, I took 5 additional graduate classes at Lehigh University in metallurgy too. So I've taken a lot of classes. I was fortunate to be able to take a 2-week class at the Kellogg School of Management at Northwestern University. It was called Shaping Innovative Leaders, and you learn about finance and how to read a financial report. A lot of great information. I really enjoyed that. The branding of products, which is of course important at the SSAB, and how branding comes about and how to market. So it was a really super course, but I've taken tons and tons of courses. The bottom line is, I guess, throughout one's career, you need continuous education. You really do, to keep up with the times. Highly recommend it if you're not doing that to continue to take classes.
Throughout all your coursework, did any of your professors mentor you in any particular way?
I've had great people all through my career, whether it be at work, professors, colleagues. And then one thing I learned about myself, I need to be around good people, which kind of steered my career. I've had many opportunities over the years, I'm sure, as you have, where I've been offered more money to go to another company, but you'd be a superstar surrounded with maybe average people, and that just was not appealing to me. I always wanted to be around good people. Some of the professors at Muhlenberg, Dr. Boyer, Dr. Raub, Dr. Loy, Milliken, they were all good. But I already told you about Dr. Boyer helping steer me into engineering. At Penn, I had two excellent professors, Dave Pope, who was my advisor, and I've worked very closely with Professor Charlie McMahon, who is a world embrittlement expert, and happy to be part of his embrittlement group. So when I was at Penn, it was kind of a halcyon of activity as far as ferrous metallurgy and embrittlement studying. In my case, I studied creep embrittlement, but tempered embrittlement, tempered martensite embrittlement, hydrogen embrittlement, stress corrosion cracking. So all students studying all these areas, and then every month there'd be a seminar, and I'd have to give a seminar. But also there were a number of postdocs that were excellent. I got to work with Dr. Kenji Abiko, professor at Tohoku University in Japan. And when you can imagine starting as a physics major and going to Penn, and so you start taking metallurgy classes, but also you're starting a thesis, and you really don't know a whole lot. And Kenji Abiko was there. He helped me with machining and setting up experiments and designing equipment. Very helpful. And he used to mock me kind of jokingly that when I first started, I maybe did some dumb things in the laboratory, and he would say, "Baby work, you're doing baby works." And then, I'd maybe do something well. "You're getting well now," he would say. And one time, I had to give a seminar, so talk about my research as part of this embrittlement group. It was like my first talk ever. I was pretty nervous. And Kenji said, if you do a good job, you come over to my house and my wife will make you, a traditional Japanese dinner. And I thought, oh boy, what am I getting into? Raw fish, and I wasn't sure what to do, but I gave a decent talk, I think. And he invited me over to his house, and I was pretty nervous about that. And his wife made this beautiful steak dinner. It was fantastic. He was good to work with. Clyde Bryant taught a laboratory class. He worked at GE R&D for a long time, and now he's a professor at Brown University. He was very helpful. He was a guy I could go to, with questions, and felt very comfortable with him. He was an excellent instructor as well. And then Samir Banerjee, maybe from Caterpillar over the years, and Samir, when he was at Penn, studied tempered martensite embrittlement, probably published about 10 papers in MetTrans on the subject, and actually Charlie McMahon asked me to review some of those papers, so I was really impressed with the guy. And he asked some questions at my seminar, kind questions. So he was kind of very gentle, very nice, and I've had a lot of interactions with him when he was at Foot Mineral and in Caterpillar, and I actually got to speak at his retirement party. Really good. And I have 3 books that always on my bookshelf. I have a lot of books, but 3 books that if you don't have, you might want to get copies of. The first is The Embrittlement of Engineering Alloys, and it's written by Clyde Bryant and Samir Banerjee, and it's really good. All kinds of embrittlements, stress corrosion cracking, good, an excellent textbook on that. And then when I first started working on structural shapes, I got into high strength low alloy steels, microalloyed steels, and I learned that the Bible for microalloyed steels was Microalloying 75, which is a long time ago. Many of the papers are still germane today, and it's an excellent book. And then the last book is Boron and Steel. It's a conference that Samir Banerjee organized. And in fact, at Caterpillar, they kind of jokingly call him Dr. Boron, since he organized this conference, a lot of boron steels. And I got involved with boron steels also on structural shapes, the track shoes, on these tracked bulldozers and the like, all made from a structural shape, a boron steel that's heat treated. So those three books, I always remember Samir, really good. And Embrittlement, I said at his retirement party that in addition to Dr. Bourne, you could call him Dr. Tempered Martensite Embrittlement as well, because he had written these 10 papers in Met-Trans.
Did you have any classmates that influenced your studies or your career?
There were three classmates that I really hung around with at Penn. My best friend at the time, Bruce Metzger, he passed away at 59. So we spent a lot of time. A typical day at Penn, we'd get into the office about 8, work on research, take classes. 5 o'clock we'd go to the gym and play basketball. I probably played the best basketball in my life, probably in the best shape of my life, playing every day. And then we'd come back and study. And then we'd go at 9 o'clock and we'd go make dinner at either his apartment or my apartment. We'd eat together and then crash for sleep. But yeah, we studied a lot together. And then there were two Scotsmen, Mike Byrne and Alan Cram. Perhaps you've heard of both of them, but and all 4 of us ended up working at Bethlehem Steel. So then Mike and Alan, they were my go-to guys. They were primary end questions, questions on steel making or degassing or casting. They were the guys I went to. Mike, he became the director. He became my boss at Homer Labs for a while. And then he went on to Timken to work and then retired. And Alan Cram, he was at Bethlehem Steel, then he was at Carnegie Mellon as part of the Center for Iron and Steelmaking Research. And then now he's, I think, at IIT, Illinois Institute of Technology, as, I want to say, provost. Or he's done very well for himself, but those guys not so, in recent years I haven't been in touch with them too much, but they were my go-to guys, and I'm fortunate to know all of them.
You had mentioned earlier that you were working on your thesis there. What was your thesis and how did it help you out with your career?
Well, my thesis was the effects of impurities on creep rupture properties of martensitic 2 1/4 chrome 1 moly steel. And it was a project sponsored by the Electric Power Research Institute. And so, it helped me with writing because each quarter I had to write a quarterly report. And prior to that, I'd taken a lot of math and physics classes, and I could do problems, but I was not a great writer. And that was probably my first writing experience, similar to Colorado School of Mines. Every 6 months they're writing in the ASPPRC group. They're writing semi-annual reports. I think it's excellent for students. But how to design an experiment, how to run an experiment, how to build equipment, how to maintain equipment, vacuum pumps, and need maintenance. How to analyze data, how to draw conclusions, how to write a thesis, how to write first publications. An excellent experience, and my preference, I think, at hiring is hire a master's, a PhD student, but particularly a master's student with a thesis. I think is important. And the EPRI experience, I guess we'll get into later, helped me get into Homer Research Labs, which was a great place to work.
Did you take any co-ops, internships, or summer jobs that helped you out with your career later?
So co-ops, I guess at Drexel, right next door to Penn, co-ops were popular. But at that time, co-op programs, I don't think were all that, or internships were all that prevalent. If I had been offered, I think I would have taken it, and I see it as a great way to preview students. So during the course of my career, I think I hired 43 co-ops, interns, and it's a great way to preview a person, see if they're a good worker, and then perhaps hire them later. Summer jobs, we talked about camp counselor, working at Fine Container, working at Thermoelectric, all very good. And particularly when I worked at Fine Container, part of the job was loading trucks. And at the Thermoelectric, loading these heavy spools of wire into a machine. I got pretty strong from those experiences, which helped me with my athletic career as well.
Did you have any political or cultural events affect your studies?
Interestingly, and I've watched a number of the oral recordings, and the Vietnam War and the draft. And actually, I can remember my freshman year, a number of us sitting around in a room and waiting for your draft number, coming from a lottery. And my draft number was 26. And I remember there was one guy in the class, he had a 4.0 freshman year, and he was number one. He enlisted right away. And so, I was going to Vietnam. I was not excited about it, but I decided I was going to serve my country. And in the fall, I guess it was 1972, I actually had to go in Newark, New Jersey, and have my draft physical. And if you've seen the movie Alice's Restaurant, it was a lot like that. I can remember a guy in front of me eating aluminum foil. They're going to take my X-rays, and I'm going to fail. Am I going to get out of the draft? And it was just a bunch of crazy people, and you're thinking, oh boy, I'm going to go to war with a bunch of people like this. So it was kind of scary. And the day that I had to go for my draft physical was the day that Muhlenberg was in the finals, the NCAA finals, small school soccer tournament, which we lost. And I played fullback in soccer, and the center fullback broke his leg. And I would have seen a lot of playing time that game, and I was sorry I wasn't there. So it really affected my athletic career, but really made an impression on me. Fortunately, not too much later, they did away with the draft, and I didn't have to go, but that was a scary time. I was fortunate to be at Penn during the bicentennial, so 1976. And that was very neat. They cleaned up the city, painted the subway, got rid of all the graffiti, everything was clean. Every night there were fireworks in different parts of Philadelphia, and I think we went to all of them. So it was a great time to be in Philadelphia. A lot of people there touring the city at that time, and it disrupted from a class standpoint. The other kind of interesting thing, a little bit off topic, is the first Rocky movie came out, and I was there, and Carolyn and I saw that movie, I think the first release, so we saw the first time it was shown. And we knew Philadelphia at that time, we knew pretty, the Italian market, so we spent time down there, and you're climbing up the art museum steps, and of course we had done that too. It was kind of a neat time.
So Rick, how did you get your first professional job in the industry?
Okay, well, I was at Penn, and Charlie McMahon, he had good contacts at GE and Westinghouse, largely due to embrittlement of rotors, and so I interviewed at GE Schenectady, Westinghouse Pittsburgh, then not too far from Philadelphia's Blue and Steel in Coatesville, so I went to Coatesville, took the train to Coatesville, interviewed there. I interviewed at Bethlehem Steel Homer Research Labs. That's where I met George Vandervoort. And then I interviewed in the Bethlehem plant of Bethlehem Steel. And I guess GE was Schenectady. The town was not great. Pittsburgh was pretty far away. That was a 6-hour drive. And Luke & Steel, I actually did not get into Luke & Steel, so I don't know what happened there. I don't know if they ever hired. Maybe they stopped hiring. I interviewed for 2 jobs at Homer Labs, and one was a machinability expert, which I essentially had no experience with, and the other was drawn and iron cans. At that time, beer cans, soda cans were made of steel, 2-piece, and going from 3-piece to 2-piece cans, where you'd have to have very clean steel to draw the long cup, and then put a top on it. And of course, that business has gone away. It's all aluminum cans now. But I really didn't have the experience for those 2 jobs. I really didn't know what they were looking for. At the end of the day, they said, "Well, you really don't have the background." And I said, "Yeah, didn't you read my resume?" I mean, it was kind of a bad situation. I was well, you kind of wasted my day, and we both wasted each other's time, I guess. The good news of that interview, I did meet George Vandervoort, and he was doing failure analysis, and he worked for a group which I ended up working at later, the Metallurgical Services and Investigations Group. And all the litigation in the company came to that group. So really interesting. Failures, auto train, there was a big train that crashed. George worked on that, did all the metallography. It was kind of a very cool job, and it had nothing to do with Bethlehem Steel. So Bethlehem Steel was not at fault. But anyway, and then I ended up interviewing for the Bethlehem plant, and I remembered that when I was looking for jobs at Muhlenberg, there was a Muhlenberg graduate or alum that was the assistant chief metallurgist in the Bethlehem plant. Somehow I remembered that. I wrote him a letter. He invited me in to interview. First time I really saw a steel mill, integrated steel mill, and it had everything in it. Very interesting, and I got a job there. And it turned out to be a great place to start.
What facilities did the Bethlehem plant of Bethlehem Steel have?
They just about had everything, and I went everywhere, saw everything. It was an excellent place to learn. So they had coke, with integrated plants, the coke ovens. They had the Blue Goose, which my brother-in-law helped invent. It was a quench car, so when they would push the ovens, would capture the coke, so the emissions wouldn't be given off, and then they would quench right in the car the coke. So it was pretty cool. They had a railroad turnover, so when the iron ore came over, in the winter the ore would freeze. They could turn the whole car upside down and empty it. It's kind of neat. There was a sintering plant. There were 5 blast furnaces there, small blast furnaces compared to nowadays. 2 basic oxygen furnaces, 5 small electric arc furnaces. They're only like 50 ton. 2 electroslag refining stations, 5 foundries. So an ingot mold foundry, an iron foundry, brass foundry where they made copper tweers for the blast furnace, a steel foundry where they made steel castings, and a roll foundry made cast rolls that are used, for example, in a hot strip mill for work rolls. There were rolling mills there, a tool steel billet, 12-14-inch bar mill, 3 structural mills making structural shapes, a drop forge, a hammer forge, press forges for making rolling mill rolls, like the backup rolls at Burns Harbor that you're familiar with on a plate mill, and heavy forgings like turbine rotors and parts for Navy nuclear aircraft carriers, submarines. Machine shops, number 2 machine shop at one time was the largest machine shop in the world. It was about a quarter-mile long. And of course, all kinds of heat treatment facilities, including vertical, where you take a big turbine rotor and vertically heat treat it while it's spinning to get uniform temperature. So, very interesting place to work.
Very extensive facility. Were you asked to give any tours?
Yes, when I first started, I was told every month you will give a tour, and I did that for several years. And my initial reaction was, I have a master's degree. I'm stooped to giving tours. But it turned out to be one of the greatest things because it got me all over the mill to see everything. So I've given tours of all these facilities that I've talked about. So you don't embarrass yourself. You have to learn all the facts. You know, this facility was built here and, started here. This is what you make and so many tons and all that kind of information. And, after a while, you got all that down. And so you gave me a tour of the 160-inch mill, I remember, so you know what it's like. And it forces you to learn the processes, the products, and to make contacts in the mill. You need to know people to get things done. You get a pretty good idea of what's going on. And I learned, I was told, so this mill was like 5 miles long along the Lehigh River. And to walk through the mill instead of driving, I said, I need to go to the machine shop. So walk through facilities as you go there. You will learn more, see what's going on. And I took that to heart. And I learned to love essentially the tours as a great teaching tool. And now we have house safety and housekeeping tours. And I encourage other researchers to get involved and get to places underneath the rolling mill, places that you would never go, or underneath the reheat furnace type of thing, to really get to know the mill and understand it. So it's a great experience. And so I used to give tours, there would be buses of people. And this is how I first met John Spear. Well, actually, I met John Spear in 1983. He came to work at Homer Labs. And I met him in the hallway, and first we met, he says, I know you. I said, well, how do you know me? You don't know me. He says, yeah, when I was a sophomore at Lehigh, you gave a tour. Professor Wayne Kraft had a tour. So there was a Lehigh bus, came in the mill. I got on the bus. I had a bullhorn. And we drove through the mill, stopped at different stops. I must have impressed John. John was on the tour, and he remembered that. And maybe it got him a little bit more excited about metallurgy.
So besides giving tours, what were the first few years of your career like working as a looper in the Bethlehem plant?
Yeah, so I got hired at the Bethlehem plant as a looper, so meaning a management. So you're going to work in different jobs, setting you up to become a manager. And I first worked as a laboratory investigator doing failure analysis of most of the products in the Bethlehem plant. So tool steels, customers got a tool steel and there's a quench crack, and why did this crack? Or he's embrittled the steel. Why is this steel embrittled? So not only tool steels, heavy forging, structural shapes, and a lot of maintenance items. Actually, all the corporate maintenance items came to the main lab in the Bethlehem plant. So I got to work on crane hooks and copper fittings and all kinds of things. Then I worked as a tool steel technical assistant, trying to answer claims, customer claims. So why do we have a claim? How do you improve yield? How do you reduce rejects? A lot of things that I'm sure you've been involved with of products. And when the foreman went on vacation during the summer, I filled in as a foreman. So that's kind of interesting, being a foreman. I learned the word ship. So wait a second, the decarb layers doesn't meet spec. Ship it. Or it's a little bit out of round. Ship it. Then I worked as a product engineer for forged hardened steel rolls. That was interesting because I was involved from melting. So I'd go to electric furnace, watch the steel melted, or go to ESR facility, watch it melted. Bottom pour of electrodes for the ESR facility. They have vacuum degassing, so familiar with vacuum degassing. Forging, heat treatment, all the machining. And then when there was failure analysis, a roll would come back from the customer. We actually had field metallography back in the 70s, late 70s. We have that capability at SSAB R&D now as well. And then the last position, I worked as a specification metallurgist for forgings, essentially addressing orders. Orders would come in, so what steps, how would we make this, what ingot size would we cast, all that, how would it be forged, upset, blocked, and the like, all the testing and all that. And then when new specifications came in, reviewed specifications, made comments that would go back to the customer. So it's really a really good start.
Do you think this provided you with a good foundation for the balance of your career?
Absolutely. I was exposed to a lot. I was very fortunate, and it's a shame that plant is closed down by and large now. I guess Lehigh Heavy Forging is there, where SSAB is buying backup rolls. That's about all that's functional these days. Yeah, it helped me get into Homer Labs. Of course, when I was in the mill, a lot of times I ran up to research. So you have to go up the mountain to research. Homer Labs on top of the South Mountain. You can look out all over. It was a great place to work. I met George Vandervoort several times, and he had a career similar to me in that he started in the plant, then came up to research, and saw the advantage of really learning the products, the process, warts and all the problems. So you know all the problems, what to work on. And when I went up to research, that really helped me. And so I would go up with George, hey, I need to do some color metallography, use his metallographic capabilities there. Or I need to use the electron microscopes. So I was at research a lot, and I maintained that relationship. But George was an excellent mentor to me.
Did you have any difficulties in transitioning into the profession?
I didn't really have any problems, but it was different. I learned that, in addition to being book smart, and I did a lot of reading, read a lot of papers, you also have practical knowledge, how to get things done, who to talk to. There's a sense of urgency, and I'm sure you know that some people want to study everything to death. You can't. I mean, the mill is down. There's a problem. We need to get that mill back up and running. So you only have a very short period of time to make a decision. And as an engineer, you need to be a risk taker. You don't have all the information. Decisions need to be made. And one of the key things is developing relationships with coworkers. If you're going to get things done, you're going to have to rely on other people, and they need to trust you. And so the building relationships is very much key.
What were your biggest challenges in adapting to working in heavy industry?
You have the not invented here syndrome. So, as a young engineer, you're full of ideas. You have ideas. Oh, we've done it. We're not going to change the way we do things. We've done it, 100 years like that. This is how we do things. And you really have to come with knowledge and facts and have good contacts. People trust you, so you can convince people to change. It was really, really difficult to overcome the not invented here syndrome.
What were some of your first major projects you had?
Well, when I was in the lab, I was fortunate or unfortunate to work on a number of crane hook failures. I did a lot of reading on crane hook failures, and some of my work was included in the corporate crane hook manual and purchasing specifications. How does the company purchase a crane hook and make sure there's not going to be a problem? So that was one of the first things. I worked on A2 tool steel. That's an air hardening tool steel, and it had ultrasonic indications. We were a big reject. It was a major reject at the time. And they made the product by three means. They could roll a wide flat in a rolling mill. They could hammer forge from a billet, or they can press forge such a product. And at that time, of course, there was no Excel work, spreadsheets, everything by hand, you know, taking down data, lots of reject data, and analyzing it. And I found that press forging actually gave you the best consolidation. And then hammer forging and rolling was last. And we were able to change the product over, certainly the wide flat product, change that over to press forging and reduce rejection rate. And that work probably would have made a great publication, but at the time I didn't even think about it. I was not thinking about publications, but I'm really, really proud of that work. And unfortunately, I didn't keep those reports that I wrote on the subject. Another one was I worked in ingot mold foundry, and the problem at ingot mold foundry, or torpedo car would come over to the foundry, and they would pour ingot molds, so making molds to make ingots. And if you poured too hot, you'd have a breakout, and they would spray with water, and there'd be steam explosions. Really difficult situation. So how can you speed up the casting process and get the temperature down? And I was there for 6 weeks recording temperatures of casting. And what we ended up doing is dipping billets and blooms into the torpedo card to kind of chill the iron to get it down to close to a casting temperature, so you didn't have a high superheat temperature, and did not have breakouts then either. And so that was an interesting study, and this study was in the middle of the winter. And so if you've been in you've been in Burns Harbor, close to Lake Michigan, and the cold coming off of the lake, so cold. But then you're casting, and then you're hot. Everything heats up. So that was interesting. And the Carolyn had bought me a tie. A silk tie. At that time, it was maybe a $35 tie, and I had my greens on. I had my mill uniform, but the top of the knot of the tie was exposed. And if you work in a foundry, there was kish and silica flying all over the place. I didn't have a respirator, so I was breathing for 6 weeks. That and the graphite all over the tie. This was totally black when I walked out of the shop. So I learned not to wear good clothes in the mill. But yeah, that was an interesting experience.
Because that's right. Because Bethlehem Steel employees, management had to wear suit and tie, wasn't it?
We had suit and tie, but then we had a mill jacket. Yeah.
Significantly different from today's standards.
Today, yeah.
Being in the mill.
Yeah.
Did you have any mentors while working at the mill?
I did have a number of mentors. When I worked in tool steel inspection, Bob Marsilio, he was a great rider, and he became a champion for me. First one in my career. Really kind of pushed me along that, hey, this young kid's pretty good. We ought to be considered for other positions. So that was really good. Ray Capolini worked as a corporate product manager in the forging area. I got to know him because he was responsible for crane hooks, which were forging. And so, eventually, he came across an EPRI project called High Purity Steels for Utility Components. And I had the experience with my master's degree working on an EPRI project. And that also helped me get into research, so he was very helpful. George Vandervoort, we talked about, he worked at research, very good mentor. Then when I got into research, one of my first supervisors was Bruce Bramford, who has passed away, good friend, mentor. Get involved with societies, write papers, get involved with committees, a lot of good guidance, telling me some of the things that I wrote, they're not very good. That no, you need to improve your writing. And at that time, I was working on heavy forgings, and they were going to put in a new 10,000-ton press. And I learned from reading literature, people were modeling forging using plasticine or clay in the laboratory. And I told Bruce, we really need to do this. And of course, management shot it down. Hey, you're a physical metallurgist, you can't do this. And Bruce and I went ahead anyway. We started and founded the physical modeling lab. We did a lot of key experiments. We wrote a paper that won the Tannenbaum Award, which at that time was the best paper in the mechanical working and steel processing division of the Iron and Steel Society. Really did some neat work. So yeah, I learned to, sometimes you need to draw a line in the sand that, no, we need to do this, even though it wasn't popular. And then it was accepted. And then Steve Hansen, he was my boss of the 44 years that I worked. He was my boss for 25. Absolutely outstanding. Smartest guy I know. The ability to manage so many things and stay on top of so many things at once. We did a lot of good research together, writing, reading. I think we have a number of patents together. I think we wrote 15 papers together. Really, really good. And he remains a good friend of mine. And that's one of the reasons one of the main reasons I came to IPSCO SAB, because of Steve Hansen.
So what eventually led to your transfer over to Homer Research Laboratories?
Well, I knew the plant and the products, and I knew their problem areas. And I knew I could help them in research if I was there. I got the encouragement from George Vandervoort. Ray Cappellini wanted to do this EPRI project, and I knew I could do this. I wanted to head up this project, and eventually wrote a proposal, and we got the project, and was able to bring in, I think, almost $3 million into Bethlehem Steel research from contract research that we did on the outside. And I remember the chief metallurgist at the time, Jerry Hageman, called me in his office and said, I really don't want you to go. I mean, he had plans for me to maybe chief metallurgist someday in the plant. And I said to him, I really want to do this. I really want to do this EPRI project. I really can help you with all your products, because I know the problems. I can work on them up there. I want to do this EPRI project. And he said, well, if that's what you really want to do, I'm not going to stand in your way. But he was not happy that I left.
What other engineering positions did you hold, and where?
Well, up at Homer Labs, I was a research engineer in the Metallurgical Services Investigation Group, and that was a very interesting job. And then I became a senior research engineer, and I worked in several different product development groups, and developed over the years expertise in steel castings, heavy forgings, including physical modeling with plasticine, rolling mill rolls, plate, bar, rod, wire, rail, and structural sheets. Structural shapes, that is. And sheet steel is probably the only product that I've had very little interaction with. At one point, I did have the welding lab where we did weld qualifications, where we would have so many spot welds being made on sheet products to show that the tip life of a spot welder could last so long, and you can make good welds. But yeah, I've worked on just about everything but sheet steel.
So what are some of the biggest technical or other challenges you experienced as an engineer?
Big challenge when I started working on forgings at research. And one of my first assignments was a problem we had with heat indication testing of chromoly V high-pressure turbine rotor forgings. And to make a turbine rotor forging, I remember there were 55 manufacturing steps. A very complicated product, probably one of the most complicated products. There's so much machining, heat treatments required, testing, all kind of testing, mag particle, ultrasonic testing, and this heat indication test. So one of the final tests, the rotor would be put in a lathe, turned at a certain rate, and you put a furnace on top of the rotor. So the rotor is heated up to its maybe operating temperature that it's going to see in service, and then you would measure run out. So how did the rotor run out or distort? In other words, it didn't turn perfectly round, and you were allowed 0.02 of an inch run out. And we had a number of rotors that exceeded that, and they had to be scrapped, could not be used, and a very expensive product. And it turned out that the solidification pattern in an ESR ingot was non-concentric. It was non-concentric due to the magnetic fields that were there. And we ended up, so we did a lot of pre-work where we etched 60-inch diameter ingots. We cut forgings apart longitudinally and etched. Just incredible amount of work. And I wrote reports documenting that. And then we shielded, we put a plate around the mold, the copper mold in the ESR furnace. And bottom line was that reduced the magnetic fields by about 20%. Still had the problem. And the next step would have been to shield the bus bars for the furnace with heavy plate. We never got to that. They shut down the furnace. It was an interesting problem. I did a lot of dilatometry showing, the expansion due to the segregation of different quadrants, keeping track of clock location. Then I worked on HPS 70W, high performance steel, weathering steel. And there's a difficulty meeting the minimum yield strength, 70 KSI. Perhaps you're familiar with that. At Montpelier, the way the product is made, if you fail yield strength, then they put it in a hot stack of plates, try to get a temper aging effect to bring back the yield point, to raise the strength. Also, temper any martensite or MA constituent that might be there, and perhaps get a little bit more precipitation strengthening. Very difficult problem. At Burns Harbor, they put the plate right through the furnace quickly to temper age. But that was an interesting problem. Coarse niobium-rich particles. This is a problem that I first saw Sparrows Point plate, back when the Sparrows Point mill was making plate a long time ago. We saw this in Steelton problem, in rolls. Steelton cast ingots for rolls. We saw these coarse particles, which of course have a negative effect on toughness and strength. And then at IPSCO, we've seen them in a lot of products. And so it's been a project I've been working on for a long time. When I joined IPSCO, Sunday Abraham at IPSCO was working on this. So we kind of got together, we published some papers, and we just published this past week in MetTrans, we think maybe the definitive paper on coarse particles. So really proud of that. A lot of good work done there. And the last thing is, one of the most difficult things for metallurgists to do is to write a specification. And I see now that there are courses out there to do this, which is desperately needed. But a lot of people read specifications as you do, ANSI and ASTM, specs and how to do things, and I'm sure there's questions all the time. Well, what do they mean by that? Or they don't really address this problem that I'm into, and I was involved with writing the A945 HSLA 65 grade, largely used for Navy ships. So I wrote part of that. So I went through the process. Very interesting.